Yes, students. So today, we are going to start our first chapter. So in our textbook, so that is real numbers. That is real numbers. So we are going to learn about real numbers. So before in our previous classes, we learn other number systems like set of natural numbers, set of whole numbers, set of integers. So these three number systems we discuss, and also we discuss about the properties of all these number systems and how to add, how to subtract, how to multiply and how to divide, these fundamental operations how to do. So in natural numbers, in whole numbers and integers, that we did. See, again we recapitulate what we did in our previous classes. Okay, students? See here, first we discuss set of natural numbers. Set of natural numbers. Set of natural numbers are represented with a letter capital N. So represented with capital N. So what is there in set of natural numbers? In the set of natural numbers, so the numbers starts from 1, 2, 3, 4, 5 and so on. This is our set of natural numbers. So in this set of natural numbers, the least number, the smallest number is 1. The highest number, so that is undefined. So why the highest number is undefined? The maximum number, that is highest number, that is undefined. If suppose if I say 100 is a maximum, means highest number. If one of our students he stands and say, so 101 is also there, no sir. If I say 1000, then 1001 is there. Lakh, 1 lakh 1 is there. 10 lakhs, 10 lakh 1 is there. Crore, so 10 crore 1. So like this maximum number. So that is why we are able to say that what is the maximum number, highest number. So the least number we can say that is 1. And what is the maximum number? So that we don't know. So that is undefined number. In this set of natural numbers, so we know how to add, how to subtract, how to multiply and how to divide. The 4 fundamental operations we know very well: how to add, how to subtract, how to multiply and how to divide. And also in our daily life we are using these 4 fundamental operations in our daily life to purchase something, so giving and buying. So generally we are using this addition, multiplication, subtraction and division in our routine life. So this is know very well. So then after that, set of whole numbers. So set of whole numbers. So what are set of whole numbers? So set of whole numbers are represented with capital W, capital W. So it starts from 0, 1, 2, 3, 4, 5 and so on. So these are about set of whole numbers. So only one minor difference is there between set of natural numbers and set of whole numbers. So that is, so the minor difference, the 0 is there in set of whole numbers, but in natural numbers, so we don't have 0, we don't have 0. Then when 0 is there, so then how to add, how to subtract, how to multiply and how to divide, that 4 fundamental operations, so we did in our previous classes. Once we recapitulate, when 0 is there, then how to add. Suppose 0 plus 4. So what is 0 plus 4? So that is 4. If 0 is added to any number, so the number itself only the answer. So R, 4 plus 0 is also 4. 0 plus 4 is 4, 4 plus 0 is also 4. So anyhow, either 0 plus 4 or 4 plus 0, so that is 4 only. So this rule is called commutative property. So this is called commutative property that we discussed in our previous classes. All the properties we discuss: closure, commutative, associative, distributive. So all these properties we discuss in our previous classes. So that is why in addition, 0 plus 4, if order will change, the answer never change in addition. So like 0 plus 4, then 4 plus 0. So the answer is 4 only. So now after that, if 0 is there, then how to subtract? 4 minus 0, 4 minus 0, that is 4. 4 minus 0 is 4. So, if 0 is subtracted from any number, so the answer is the number itself, the number itself. If suppose 0 minus 4, what is the answer? If I ask 0 minus 4, so then what is the answer? So, do not say 4, 4 is the wrong answer. So, this is the least number, 0 is the smallest number. So, from smaller number to bigger number we cannot make minus, but so we did integers addition, integers subtraction. So, then what is the answer? 0 minus 4 is minus 4, you will get minus 4 is the answer, you will get minus 4 is the answer. Here if order will change, the answer will change, the answer will change. So, commutative property is not applicable in subtraction when 0 is there. So, then after that multiplication, 4 into 0, do not say 4, this is 0. If 0 is multiplied with any number, so the answer is 0, and 0 into 4 is also 0, 4 into 0 and 0 into 4 both are 0. So, if here also if order will change, then the answer never change. It means commutative property is applicable in multiplication, in addition. So, in these both cases commutative property is applicable when 0, when we operate with 0, when we operate with 0. Then divide, 4 divided by 0, 4 divided by 0, so this is undefined, this is undefined. 0 divided by 4, this is 0, 0 divided by 4 is 0, 4 divided by 0 is undefined, 4 divided by 0. Why it is undefined? Suppose your class test is for 10 marks. So, then if a student got 0 marks, then how to represent? That is 0 divided by 10. So, 0 divided by 10 means he got 0 marks, that is 0 divided by 10 is 0. If suppose if I take like this 10 divided by 0, so for 0 marks the student got 10, either it is possible? No, it is not possible. So, that is why this 0 divided by 4, 0 divided 10 divided by 0, 4 divided by 0, so 8 divided by 0, 100 divided by 0. So, like this when 0 divides any number, so that is undefined value, that is undefined value. So, these are the properties of addition, subtraction, multiplication and division with 0. If order will change, then the answer will not change in addition, in multiplication, but in subtraction and division the answer will change. So, that is why commutative property is applicable in addition and multiplication in whole numbers, but so not in subtraction and division. So, this is about when the 0 will came, then how the fundamental operations will change. So, what is actually fundamental operations, how the fundamental operations so we should do. So, this is about whole numbers. So, then after that set of integers, set of integers. Set of integers are represented with capital Z or capital I. The set of integers are represented with capital Z or capital I. So, what are there in the set of integers? In the set of integers, so we have negative numbers -3, -2, -1, 0 with positive numbers. So, here in whole numbers we know what is the least number, that is 0, and what is the maximum number, so that we do not know. So, that is also undefined. Here in set of integers, what is the least number, what is the highest number? Least number is also undefined and the highest number is also undefined. Both the numbers are undefined. The least, the smallest number, that is undefined. So, the highest number is also undefined. So, already we know that how to compare the numbers. When two negative numbers are there, so then which one is the least one, which one is the highest one. When two positive numbers are there, then how to compare the numbers, and one positive and negative number is there, how to compare. 0 with negative, 0 with positive, how to compare. All these properties we discussed in our previous classes, and also we discuss how to arrange the numbers, how to arrange the integers in ascending order as well as in descending orders. descending order. So, and also we know how to operate, how to do addition, subtraction, multiplication and division so of the integers. All these 4 fundamental operations we did. So, here basically negative numbers are smaller than 0 and positive numbers. So, negative numbers are smaller than 0 and also with positive numbers. So, positive numbers are bigger than 0 as well as negative numbers. Okay. In the negative number, so which one is the smaller, that one is the bigger. In the positive number, whatever is the bigger, that is the bigger. So, this is the comparison between the numbers. Okay. This is about the concept what we learned in the previous class. So, now in this class we are going to discuss about real numbers. So, before that rational numbers and irrational numbers, that also we discussed in our previous classes. What are rational numbers and what are irrational numbers? So, rational numbers, rational numbers are represented with capital Q, capital Q. So, which type of numbers are rational numbers? The numbers which are in the form of P by Q, the numbers which are in the form of P by Q, where Q should not be 0, Q should not be 0. So, P by Q where Q should not be 0. If denominator is 0, then what happened? If the denominator is 0, then the value is undefined. So, that is why Q should not be 0, Q should not be 0 here. Okay. So, this type of numbers are rational numbers. So, what are the numbers that are rational numbers? If I ask 0 is a rational number? Yes, 0 is a rational number. So, why it is a rational number? If a number without the denominator, so that means, so their denominator is 1, there is a denominator that is 1. So, that is 0 is having a denominator that is 1, that is 0 by 1. So, 0 is a rational number. If I ask minus 2 is also a rational number. Why? This is without denominator. Without denominator means denominator 1 is there. So, it is in the form of P by Q. Means all integers 0 and positive integers 7 means 7 by 1 is there. So, this is also rational numbers. So, natural numbers, whole numbers, integers. Natural numbers, whole numbers, integers are rational numbers. Natural numbers, so whole numbers and integers are rational numbers. And also, so what type of numbers are rational numbers? Fractions. Fractions, all fractions are rational numbers. So, that is like fractions, unlike fractions, mixed fractions, proper fractions, improper fractions, all fractions are rational numbers. And after that decimal numbers, decimal numbers. So, decimal numbers, in the decimal numbers, terminating decimals and non-terminating decimals. Terminating plus non-terminating. Terminating decimals and non-terminating decimals are rational numbers. And after that perfect square numbers, perfect square root, perfect square roots, cube roots, perfect cube roots, perfect fourth root, perfect fourth roots, fifth roots, so on. So, all these are perfect square roots, perfect cube roots, perfect fourth roots, perfect fifth roots, perfect sixth roots, seventh roots, eighth roots, ninth roots, all they are rational numbers. So, these are rational numbers. So, basically what are the rational numbers? So, rational numbers are the numbers, natural numbers are rational numbers, whole numbers are rational numbers, integers are rational numbers, and fractions, all fractions, like fraction, unlike fraction, mixed fraction, so and proper fractions, improper fractions. So, decimal numbers, in the decimal numbers, terminating decimals and non-terminating decimals. So, then after that, so perfect square roots, cube roots, fourth roots, fifth roots, so on, All these are rational numbers. So, this is about rational numbers. So, then what about irrational numbers? What type of numbers are irrational numbers? So, the numbers which are neither be a terminating nor non-terminating decimals, they are irrational numbers. They are irrational numbers. The numbers which are not having perfect square roots, cube roots, fourth roots, fifth roots, so on. So, they are irrational numbers. They are irrational numbers. What are the rational numbers and what are the irrational numbers? Irrational numbers are the numbers so who are neither be terminating nor be non-terminating decimals. They are irrational numbers, and also the numbers which are neither be a perfect cube roots, perfect square roots, perfect fifth roots, sixth roots, seventh roots. So, all this. So, the numbers which are not having perfect square roots, cube roots, fourth roots, fifth roots, and so on. So, these type of numbers are irrational numbers. This type of numbers are irrational numbers. So, about rational numbers and irrational numbers we discuss in 8th class. So, after that, so what we are going to learn in this class? Now, we are going to learn about real numbers. So, what about real numbers? So, what are the real numbers? Real numbers are the numbers which are the combination of rational numbers and irrational numbers. Rational numbers and irrational numbers are real numbers. All rational numbers and all irrational numbers are real numbers. Rational numbers and irrational numbers are real numbers. This is about real numbers. Okay. So, now we are going to discuss about real numbers. Okay, students. So, now students, see here. So, here some bags are given. So, in these bags some numbers are written. So, in the first bag 700, 101. So, numbers are there, and the second bag 0, 7 and 100 is there, and the third bag 0, 7, minus 3 and 100 is there, and the fourth bag 0, 7, 100, minus 3 by 7. So, are there. See here. So, here in the first bag 700 and 101. So, it means all these are natural numbers. So, this is set of natural numbers. All these numbers are set of natural numbers. And here 7 and 100 is there, here also 7 and 100 is there, and also 0 is there. So, when 0 is there, that means that is set of whole numbers. So, 0, so when 0 comes means here 0 came, so that means this is set of whole numbers, whole number set. In the next set, so 0, 7 and 100 is there, so with minus 3 is also there. It means negative numbers also there, negative number is also there. It means set of integers. When negative numbers are there, then that is set of integers. Now, 0 is there, 7 is there, and 100 is there, and minus 3 is also there. So, all these numbers are there in set of another bag. So, including with minus 3 by 7 p by q form. So, with p by q form. So, that means, so when p by q form is there, so then that is set of rational numbers, set of rational numbers. So, here set of natural numbers are always subset of set of whole numbers, set of whole numbers, subset of set of integers. Set of integers are always subset of set of rational numbers. Subset means whatever the numbers present in set of natural numbers, that all the numbers should present in set of whole numbers. Then after that, whatever the numbers present in set of whole numbers, all that numbers should present in set of integers. So, whatever the numbers present in set of integers, all that numbers should present in set of rational numbers. Then only we can say that that is the subset. That is the subset. Obviously, all the numbers of set of natural numbers are in set of whole numbers, and in set of whole numbers are set of all numbers present in set of integers, and in set of integers all numbers of set of integers present in set of rational numbers, set of rational numbers. Now, after that, how to represent set of natural numbers on a number line? So, that we discuss in previous classes that also. So, this is number line, we should draw number line, set of natural numbers. So, we should take positive numbers with equal difference. So take equal difference and write the numbers. So starts from 1, 2, 3, 4, 5, 6. This is about set of natural numbers, a representation of set of natural numbers on number line. Then set of whole numbers. How to represent set of whole numbers on number line? So this also we know. So how to represent? So exactly in the middle, so we should take 0 with an equal difference. So represent other positive numbers. So 1, 2, 3, 4, 5, 6, 7, so on. This is about set of whole numbers on number line. Then how to represent set of integers on number line? Set of integers. So integers again on number line in the middle. So we should take 0. So with equal difference we should take positive numbers on right side, negative numbers on left side. So here 0, 1, this 0 is over. 1, 2, 3, 4, 5, 6, 7. Here minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. These are the representation of set of integers on a number line. Set of natural numbers on number line, set of whole numbers on number line, set of integers on number line. Then how to represent set of integers on number line? First we should take 0 in the middle, and right side we should take positive numbers, and left side we should write negative numbers with an equal difference. With an equal distance we should take positive numbers on right side and negative numbers on left hand side. Then after that, so then how to represent rational numbers? Suppose rational numbers are in the form of p by q, in the form of p by q. So suppose 3 by 4, 3 by 4 how to represent pictorically, means pictograph. So how to represent pictorically? So that is pictograph. So 3 by 4, so we can represent, first we make 4 equal parts, 1, 2, 3, 4. In these 4 equal parts, so we should shade 3 parts, 1, 2, 3. This is 3 by 4. So this is 3 by 4. Okay. This is 3 by 4 pictorically, or otherwise, so by taking a circle also we can represent. So half of the circle and 1/4. So 3/4 how to represent? So 4 means total we make 4 parts. Out of the 4 parts, so 3 parts we should shade, 1, 2, 3. This is 3 by 4, 3 by 4 pictorically. So this is pictograph. So how to represent? So the graph means the number, the rational number pictorically. So this is the representation of the graph, means pictorial representation of rational number. So if all the numbers can represent pictorically, so all the numbers of all rational numbers, whatever the number is given, so we can represent pictograph, means pictorically we can represent? No. So it's very difficult to represent so pictograph. So whatever the number is given, say in p by q form, so all the numbers we cannot represent so pictorically. So okay. Now, so then 3 by 4, how to represent the 3 by 4 on number line? So on number line, see here, so this is, so using, so pictorically how to represent 3 by 4 on a number line, how to represent 3 by 4. See here, by 4 is there, by 4, first we should concentrate on the denominator, by 4. So first, so we should take 0 in the middle, 0. Here by 4, no, start from 1 by 4, 1 by 4, 2 by 4, 3 by 4, now here 4 by 4, this is 1 by 4, start from 0, this is by 4 is there, no, starts from 1 by 4, this is 2 by 4, 3 by 4, here 4 by 4, so that is equal to 1, 4 by 4 is 1, then after that here minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4. minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4, which is minus 1, is equal to minus 1. So, by 4, if by 4 is there, starts from 1 by 4, 2 by 4, 3 by 4, 4 by 4. So, if by 7 is there, then starts from 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, 7 by 7. If 7 by 7, if numerator and denominator is same, so there the value is 1. There the value is 1. So, according to the denominator, how to follow, so that we should think, and according to that, so we should represent number line. We should represent the given rational number on number line. Here 3 by 4. Where is the 3 by 4? Here. Here is the location of a 3 by 4. So, then if anybody asks, so all the rational numbers can represent on a number line? No doubt, all the numbers can represent on number line. So, but pictorially, so all the rational numbers cannot be represented. It is difficult to represent all the rational numbers, so by pictorially. So, but so all rational numbers we can represent on number line very easily. Okay. So, now, so in example 1, so represent 5 by 3 and minus 5 by 3 on a number line. So, number line, so we should represent, so these two, so rational numbers, these two rational numbers we should so represent on number line. So, solution. First we should draw a number line first. So, you draw a line, so with a scale, you should draw a line first. So, then after that, in the middle you should take 0. Here in the first fraction, the second fraction, by 3 is there. So, in the denominator by 3 is there. So, we start from 1 by 3, 2 by 3, 3 by 3, 4 by 3, 5 by 3, 6 by 3, 7 by 3 and so on. On left side, minus 1 by 3, minus 2 by 3, minus 3 by 3, minus 4 by 3, minus 5 by 3, minus 6 by 3, minus 7 by 3 and so on. See here, 0, here 1 by 3, next 2 by 3, here 3 by 3, here you will get 3 by 3, which is 1. If numerator and denominator is same, so that value is 1. Then 3 by 3, 4 by 3, 5 by 3, 6 by 3. So, it will cancel in 3 table, 3 ones are 3 twos are, which is equal to 2. And after that 7 by 3. If 3 multiples are coming in the numerator, so then that will cancel. So, where it will cancel? So, the value is that much. Okay. So, here 3 multiple is there, 6 is a 3 multiple. So, 3 twos are 6, so that value is 2. Okay. Now, here minus 1 by 3, here minus 2 by 3, here minus 3 by 3, which is minus 1, here minus 4 by 3, here minus 5 by 3, minus 6 by 3, here 3 multiple, so that is minus 2, 3 ones are 3 twos are, that is minus 2, here 7 by 3, that is minus 7 by 3. So, these are the values on the number line. So, what we should represent? 5 by 3 plus 5 by 3 plus 5 by 3 means on positive side, plus 5 by 3. Here we have plus 5 by 3. This is plus 5 by 3, and after that minus 5 by 3. On the left side we have minus 5 by 3. Here we have minus 5 by 3. So, this is plus 5 by 3 and minus 5 by 3 representation on number line. Okay. Now, so in do this activity, what he has given the question. So, represent minus 3 by 4 on the number line, plus 3 by 4. So, already so we did. So, here minus 3 by 4 he is asking. So, here, so first we should draw a number line. In the middle we should take 0. Then after that by 4 is there. Here by 4 is there in the denominator. By 4 means we should start from 1 by 4. 1 by 4, 2 by 4, 3 by 4, 4 by 4, 5 by 4, 6 by 4. minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4, minus 5 by 4, minus 6 by 4. Here plus values on left side, 1 by 4, 2 by 4, 3 by 4, 4 by 4, 4 multiple means that is equal to 1, 4 ones are 4. Here 5 by 4, 6 by 4. Now here minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4, which is minus 1. Here minus 5 by 4, minus 6 by 4. So what he is asking, minus 3 by 4. Minus 3 by 4, the minus value is on left side. Where it is? Here we have. So minus 3 by 4. This is our representation. Minus 3 by 4 on number line. Now after that, write 0, 7, 10, minus 4 in P by Q form. The next question, P by Q form. So it is also very easy to represent. 0, then how to represent P by Q form? 0 by 1. Then 7, how to represent in P by Q form? 7 by 1. Without denominator means by 1 is there. Then 10, in P by Q form, 10 by 1. Minus 4 is integer, so that is 4 by 1, minus 4 by 1. So nothing, no denominator is given means by 1, so we should take as a denominator. So by 1, denominator is by 1. So all these are in the form of P by Q. So if without denominator of our numbers given, so then how to write in P by Q form? Just by taking 1 in the denominator. If you take 1 in the denominator, so that will in the form of P by Q. Okay. So here, so in the third question, he has given one activity. So you and your friend, so you both sit together and you ask your friend, so to say some integers from 0 to 100. So if your friend asks some integers from 0 to 100, so you say integers from 0 in between 0 to 100. So if you say your answer in terms of yes or no. So if you say correct answer in between 0 to 100, then you say yes, otherwise no. So then in that, what strategy you are following? So just, so integer means 0 to 100. 0 to 100s are the integers only. So but they are positive integers. Here the question what he is asking. So one doubt will appear here. So what is the doubt? 0 to 100. 0 to 100s are not integers. So you say they are whole numbers. 0 to 100s are the whole numbers, but he is asking integers. All whole numbers are integers. Either he is asking the question from 0 to 100s are whole numbers, that is also correct, but integers also correct. Why? Because all whole numbers are integers. So positive numbers you should say, don't say negative numbers. Why? Because 0 to 100 he is asking, it means positive numbers he is asking, okay. So that you should say positive numbers only, that strategy so you should follow. Okay students. So now in example 3, what he is asking, see students, so find two rational numbers we have to find. So between 3 and 4 by mean method. Here we should apply mean method and to find so rational numbers. Mean method, what is the mean method? First draw your number line here 0, 1, 2, minus 1, minus 2, minus 3, here plus 1, plus 2, plus 3, plus 4, 3 and 4, between 3 and 4, so like this, here 3 is there and here 4 is there, between 3 and 4 two rational numbers we should find. So then how to find two rational numbers between 3 and 4? See here, so by mean method, so how to find? So using mean method, rational number between 3 and 4 is, so by using mean method, see here, so just we add 3 and 4 and so make it by 2, means average of the 2. Mean means so add divided by 2, average sum of the numbers by how many numbers that we have to take. 3 plus 4, that is 7 by 2. So, we got one number 7 by 2. In between 3 and 4, so one rational number we got. Mean method means average. Average of 3 and 4 we should write, that is 3 plus 4 by 2, that is 7 by 2. And he is asking, how many numbers he is asking? So, two numbers, two rational numbers, one rational number we got, and one more rational number how we will get. So, after that, if you want to find between 7 by 2 and 4 by 4, so that you will get one number, or otherwise in between 3 and 7 by 2 you will get one more number. So, any one number you can get, either between 3 and 7 by 2, either 7 by 2 and 4, any number you can find. So, now I want to find the number between 3 by 2 and 7 by 2, 3 and 7 by 2. So, another rational number between 3 and 7 by 2. So, using mean method, So, what is the mean method? So, just we should add, so the numbers 3 plus 7 by 2, 3 plus 7 by 2 by 2. Here in the numerator we should take LCM of the fractions. So, how to add fractions? By taking LCM. So, 1 and 2 LCM is 2. Then after that, in one table when you will get to 2's are, so multiply with 2, 3 2's are 6 we should write, and after that plus. In 2 table when you will get to 2 1's are, so multiply with 1, 7 1's are 7, whole divided by 2, that is 6 plus 7, 13 by 2 into this fraction by fraction. How to divide? The second fraction by fraction will get reciprocal, that is 2 by 1 will get into how to take, so that is 1 by 2 we should take reciprocal, that is 13 by 2 2's are 4, 13 by 4. So, this is one of the rational number, this is another rational number between. So, two rational numbers between 3 and 4 are 13 by 4 and 7 by 2. So, like this, if you take 3 here and 4 here, 7 by 2 is in the middle and 13 by 2 is, so 3 and 7 by 2 mid, that is 13 by 4. These two are the rational numbers between 3 and 4. Okay? By using mean method, so this is the method to find rational numbers. Okay, students? So for third example, so one more method is there to find the rational numbers between 3 and 4. So the first method what we did, mean method we did, how to find using mean method. So two rational numbers between 3 and 4. The second method, method 2, using second method, how to find rational numbers between 3 and 4. First we should take 3. 3 means there is no by, means by 1 is there. So we should like equal fractions. So what about equal fractions? How you will get equal fractions? If you multiply numerator and denominator with the same number, then you will get equal fractions. Then 3 2's are 6, so 1 2's are 2, 3 3's are 9, 1 3's are 3, 3 4's are 12, 1 4's are 4, 3 5's are 15, 1 5's are 5, so on. Multiply with the same number. If you multiply 3 by 1 with 2, then you will get 6 by 2. If you multiply 3 by 1 with 3, then 3 3's are 9, 1 3's are 3. If you multiply with 4, 3 4's are 12, 1 4's are 4. Then if you multiply by 5, then you will get 3 5's are 15, 1 5's are 5. In the same way, next fraction 4, next number is 4. There is no by, means by 1. Now, you multiply with the same number, 4 2's are 8, 4 3's are 12, 4 4's are 16, 4 5's are 20, and so on. Here, 1 2s are 2, 1 3s are 3, 1 4s are 4, 1 5s are 5 and so on. So these are like fractions. Okay. So now you compare both the fractions. In which fraction the denominators are same? Here 2, here 2. So denominators are same. So here 3, here 4, here 4. So I want to take these two, 9 by 3 and 12 by 3. Take these two fractions. Take 9 by 3, that is 9 by 3, that is 3. 9 by 3 means 3, and 12 by 3, that is 4. So 9 by 3 is, that is nothing but 3 only. 12 by 3, that is nothing but 4 only. Now, so rational numbers. Rational numbers. How many rational numbers we want? 2 rational numbers between 9 by 3 and 12 by 3 are. So 9 by 3, after that 10 by 3, after that 11 by 3, after that 12 by 3. This 9 by 3 and 12 by 3. So this is greater than and this is less than and this is less than. Okay, 9 by 3 is less than 10 by 3, 10 by 3 is less than 11 by 3, 11 by 3 is less than 12 by 3. So 9 by 3 means 3, 10 by 3, 11 by 3 and 12 by 3 is nothing but 4. So in between 3 and 4, so what are the true rational numbers? So 10 by 3 and 11 by 3. So 10 by 3 and 11 by 3 are the two rational numbers between 3 and 4. So two rational numbers between 3 and 4 are 10 by 3 and 11 by 3. 10 by 3 and 11 by 3. Okay students, this is another method to find two rational numbers, three rational numbers, four rational numbers, any number of rational numbers we can find. So using this method, so we can find number of rational numbers between the given numbers. Okay, any method we can follow. Okay, so that is mean method. This is finding the equal numbers, means equal fractions, writing equal fractions. So after that we should find two rational numbers. So if you take these two, 13 by 4, 14 by 4, 15 by 4, three rational numbers you will get here in between these. Here by using these two, so 16 by 5, 17 by 5, 18 by 5, 19 by 5, 4 rational numbers you will get between. So number of rational, how many numbers so we require, so that many numbers we can find. Okay, okay students. So now fourth example. So express 7 by 16, 10 by 7 and 2 by 3 in decimal form. So we should express all these numbers in decimal form. 7 by 16, 10 by 7, 2 by 3 in decimal form. See here first, 7 by 6, 7 by 16. It means 16 divides 7. 7 is a smaller number, so at the very beginning we should take a decimal. If you take a decimal, then we can take 1 0 here. 16, 16 5s are, 16 5s are 80, 16 4s are 64. 16 4s are 64. Then if you make minus 60, you will get 60 and 0. So again 16 3s are 48, 16 3s are 48, here 2, so here 1, 12 and 1 0 we can take in each step. 16, 16 7s are, 16 7s are, 16 8s are 8, 6 are 48, 4, 8 1s are 128, 16 7s are, 16 7s are, we should take 16 7s are, 7 6 are 42, 4, 7 11, 112, then minus, so then you will get 8 here and 80, so 65s are 80, so then 80 minus 80, 0, so it is 7 by 16, answer is so 0.4375. 0.4375. Next, the next one is 10 by 7. 10 divided by 7. It means 7 divides 10. 7 divides 10. In 10 table when you will get, in 7 table when you will get 10, means 1s are 7 1s are 7. Then after that 3 left. So you take, if you take a decimal, then we can take 1 0. Then 7 4s are 28. Then after that if you make minus, then 2 left, 20. 7 2s are 14. Then again 60 it will come. 7 8s are 56. Then again 4 left, 40. 7 5s are 35. So then 5 left, 0. 7 7s are 49. So then 1 left, again 0. 7 1s are 7. Then 3 left, 0 will come. 30, again 30. Again starts from here. Means, so it's continuous so on. 438571 bar. It will continue. Again 30 came, means again all these steps will repeat again. It means 10 by 7. 10 by 7 is equal to 1.428571 bar. 428571 bar. 10 by 7 is equal to. Okay, this is about 10 by 7. Now, after that, 2 by 3. Next fraction 2 by 3. It means 3 divides 2. Then 2 is less than 3. It means we should take a point first. Then 1 0 we can take. 3 6 are 18. Then minus 2 left. 20 will come. 3 6 are 18. Again 2 left. 20 will come. 3 6 are 18. Again 2 left. 20 will come. So again it continues so on. So it continues. So 6 will continue. That means 2 by 3 is equal to 0.6 continues here, 6 bar. So it is 0.6 bar. Here bar number. These two are non-terminating decimals. Why? Because here they are repeating. So repeatedly they are coming. Here also we are repeatedly coming 428571, 428571, 428571. Here 6 digits are repeated. Here 1 digit is repeat. So either 6 digit, either 1 digit, whatever it is. These are non-terminating decimals. Non-terminating repeating. Repeating decimal. Non-terminating repeating decimal. Here also non-terminating repeating. Non-terminating repeating decimal. So this is terminating decimal. Why? Because here, so remainder we are getting 0. It is not repeatedly coming. So this is terminating decimal. It means from these means decimal forms what we conclude. So either a terminating or non-terminating decimals can express in P by Q form. Terminating decimals and non-terminating decimals can express in P by Q form. So that means rational numbers can means terminating and non-terminating decimals can be expressed in rational form. So indirectly terminating decimals and non-terminating decimals are rational numbers. Okay.